Okay, welcome back. Hopefully you did a little stretching and you're good to go. I know these are long notes, but once we have this in our brain, we're going to be good to go. The example at the bottom says identifying functions, and this is what you were doing when you were doing that activity right before the note-taking. It says tell whether the relation is a function. So it wants us in part A to look at example 1. So example 1 is on the previous page, on page 6. Right here, it was the spruce tree. And we need to decide if it is a function. Now our trick if something is a function is if each input has one unique output. And my trick, remember, was, does X repeat? Now X does not repeat, so each output went with one input. Each input has a unique output. So this is a function. So we would say the relation is a function because each input has a unique output. Each input has a unique output. We can't say because X doesn't repeat. That's my little cheat step. This makes sense as a single tree can have only one height at any given point in time. Now I want to point something out. What if X did repeat? What if our table had said 25 and then it said 52? That input-output pair is repeating itself. So technically X is repeating, but it's okay because it's the same output. If it had been 25, let's say 58, that's when this would not have been a function because you can't have 25 go to 52 and 25 go to 58. Okay, so let's look at part B. Part B says to look at example 2. So example 2 is the one up above. The one up above had a repeat input. This input of number 1 here goes to 1 and it also goes to 3. So this guy is not a function. So the relation isn't a function because the number 1 had 2 different outputs. The number 1 had 2 different outputs. Now I'm going to show you a different way that you could have come up with that same determination. It has to do with looking at the graph. And the graph needs to pass the vertical line test in order to be a function. And what that means is I can take my pencil or some kind of straight edge and move it across the paper, and it's going to touch each coordinate or each ordered pair at its own unique time. It can't hit 2 ordered pairs at the same time. And look what's going to happen right here. It's going to hit those 2 ordered pairs at the same time, which means this is not a function. The input 1 went with a 1 for the y and a 3 for the y, and that is not allowed. So that would be another way. And that gets us to the definition that we skipped on the previous page. So we're going to go back there right now, and we're going to put in vertical line test. To be a function, a vertical line can only touch the graph at one place at a time. To be a function, a vertical line can only touch the graph at one place at a time. Okay, so we're going to turn the page right now. And while we're turning the page, I'll give you one more joke. How do you get a peanut to laugh? You crack it up. I know, hilarious. Okay, so let's check this and make sure that you are understanding and are able to identify domain, range, and whether or not something is a function. So we're going to practice with number 1 here on the next page. Number 1, the first thing we're going to do is we're going to identify the domain. So I'm just going to write a D for domain and get my little bird brackets in there, and I'm going to list all of the X values. So they are -5, -3, -1, 2, and 5, and then close it off. Hopefully you're getting better at making those. They're not fun sometimes. The range is the Y values, and I like to put them in order as well. -1, 0, 2, 3, and 4. And then you need to identify whether or not it's a function. Well, yes, it is a function. And why is it a function? It's a function because each input has a unique output. And our trick to know that is x didn't repeat, did it? But we can't say that on a reason. We say, yes, it's a function because each input had a unique output. Okay, so now you go ahead and do number 2. Pause the video, and I'm going to show you the answer here in a second. Okay, welcome back. So the domain of this one was all the x's, all the inputs. The range was all the outputs. And this was not a function because each input didn't have one unique output. The input 3 had 2 outputs. Okay, and you can see up here I was demonstrating the 3 went with a 1 and the 3 went with a -2. Now if I had listed that as 3, 1 and I just wrote it twice, then it would have been okay. But you can't list it twice with a different number anyway. You can't have the input go with the 3. The 3 can't go with the 1 and the -2. So this was not a function. Okay, we're almost done, thank goodness, right? All right, example 4. In this one, we're going to decide whether or not they're functions by the vertical line test. So these are quick and easy. So does this one pass the vertical line test? Take your pencil or your straight edge and move it across. Does it hit anything, any 2 coordinates or more coordinates at the same time? Nope, it hits them all at their own unique time. So this is a function. What about part B? Yep, not a function. Look at that right there. They even drew the line in for you. Those 2, how can -3 go in and spit out a 2 and a -1? So this is not a function. Okay, dokie. All right, so that's the end of the notes, and you're going to continue on in the packet to the next page, which is going to be relations and functions.